In 2003, the automotive industry was a fortress, a century-old club of giants. Ford, General Motors, Toyota, Volkswagen, companies so entrenched, so massive, that the idea of a startup challenging them seemed absurd. The last successful American car company had been founded in 1925. That was Chrysler. For nearly 80 years, no one had broken into this exclusive club. Dozens had tried. Tucker, DeLorean, Fisker, brilliant minds with revolutionary ideas, all crushed by the weight of an industry that didn't welcome newcomers. And then came Tesla, not just another car company, but a Silicon Valley startup that dared to reimagine the entire concept of what a car could be. Led by an entrepreneur named Elon Musk who had no formal training in automotive engineering, no assembly lines, and no respect for the way things had always been done. This is the story of how Tesla didn't just enter the automotive industry, it detonated a bomb at its center. How Elon Musk wrote a playbook for disruption that changed not just cars, but the very DNA of manufacturing, technology, and corporate innovation. This is the rise of Tesla. To understand Tesla's revolution, we must first understand the graveyard that came before it. In 1996, General Motors launched the EV1, the first mass-produced electric vehicle of the modern era. It was sleek, innovative, and beloved by its small group of lessees. And then GM killed it, literally. Despite protests from devoted users, GM recalled every single EV1, crushed them, and sent a clear message to the world: electric cars were not the future. The reasoning was simple. Electric vehicles had limited range, maybe 60 to 100 miles on a charge. They were expensive to produce. The infrastructure didn't exist. And most damning of all, consumers didn't want them. Or so the industry claimed. The major automakers had no incentive to disrupt their own profitable business. They were making billions from internal combustion engines. Why cannibalize that success for an uncertain technology? But in Silicon Valley, far from Detroit's assembly lines, a small group of engineers saw something different. In July 2003, two engineers named Martin Eberhard and Mark Tarpenning founded Tesla Motors. Their vision was audacious: prove that electric cars could be better than gasoline cars. Not just cleaner, not just more efficient, actually better, more fun to drive, higher performance, more desirable. But vision without capital is just a dream. And this is where Elon Musk enters our story. Elon Musk had just sold PayPal to eBay for $1.5 billion. He was 31 years old and searching for his next big challenge. When Eberhard and Tarpenning pitched him on Tesla, Musk didn't just see a car company. He saw an existential mission. Musk had become convinced that humanity's dependence on fossil fuels was leading civilization toward catastrophe. Electric vehicles weren't just a business opportunity. They were a necessity for human survival. In February 2004, Musk led Tesla's series of funding round, investing $6.5 million of his own money. He became chairman of the board and the company's largest shareholder. The plan was deceptively simple, and it would become known as the Secret Master Plan. In 2006, Musk published what he called the Secret Master Plan on Tesla's blog. It was brilliant in its simplicity. Step 1. Build a low-volume, expensive sports car to prove the technology and generate revenue. Step 2. Use that money to develop a medium-volume car at a lower price point. Step 3. Use that money to create an affordable, high-volume car. Oh, and one more thing, provide solar power options too. This wasn't just about electric cars. It was about accelerating the world's transition to sustainable energy. Most people thought it was fantasy. The automotive industry scoffed. Tech blogs were skeptical. Investors were nervous. But Musk had learned something crucial from his previous ventures. The key to disrupting an industry isn't to play by its rules. It's to change the game entirely. The traditional auto industry thought of cars as mechanical products, refined over decades of incremental improvement. Musk thought of them as software platforms, computers on wheels, ripe for exponential innovation. This fundamental difference in thinking would prove to be Tesla's secret weapon. In 2008, Tesla launched the Roadster. Based on a Lotus Elise chassis but powered entirely by electricity, it was a revelation. 0 to 60 in 3.7 seconds, a range of 245 miles per charge, and it looked absolutely stunning. The Roadster did something no electric car had done before. It made electric vehicles cool, desirable, a status symbol. Suddenly, being environmentally conscious didn't mean sacrificing performance or style. But behind the scenes, Tesla was hemorrhaging money and barely surviving. Building cars is brutally expensive. The Roadster was supposed to cost $25 million to develop. It ended up costing over $140 million. Production delays plagued the company. Suppliers failed to deliver. And then came 2008. The global financial crisis of 2008 nearly killed Tesla before it could truly begin. Credit markets froze. Investment dried up. Major automakers like GM and Chrysler were on the verge of bankruptcy. For a tiny startup trying to do the impossible, it was catastrophic. Musk faced an agonizing choice. He had money left from the PayPal sale, but not enough to save both of his companies. SpaceX, his rocket company, was also on the brink after 3 failed launches. He could save one, maybe, but not both. In what he would later call the worst year of my life, Musk made a decision that revealed everything about his character. He would divide his remaining money between both companies and give each a chance to survive. If they both failed, so be it. But he wouldn't choose. On September 28, 2008, SpaceX's fourth Falcon 1 rocket successfully reached orbit. It was SpaceX's last chance. The company would have been bankrupted by another failure. The successful launch saved the company and led to a $1.6 billion NASA contract. That same Christmas Eve, Tesla closed its Series F funding round, raising $40 million when most people thought the company was doomed. Musk himself invested his last available dollar into the company, literally down to his last funds, borrowing money for rent. Tesla survived, barely. In 2012, Tesla launched the Model S, and the automotive world changed forever. This wasn't a converted Lotus. This was a car designed from the ground up as an electric vehicle, and it was extraordinary. A 17-inch touchscreen dominated the dashboard. Over-the-air software updates meant the car improved over time. The performance was blistering. The P85D could hit 60 miles per hour in 2.8 seconds, faster than almost any supercar. Motor Trend named it Car of the Year. Consumer Reports gave it a 99 out of 100 rating, the highest they'd ever given any car. The National Highway Traffic Safety Administration gave it a 5-star safety rating in every category, and it achieved the lowest probability of injury of any car they'd ever tested. The Model S wasn't just competitive with luxury sedans. It was beating them completely. So how did Tesla do it? How did a startup with no automotive heritage outperform companies with a century of experience? The answer lies in what Musk calls first principles thinking. Traditional automakers approached problems by analogy. We've always done it this way. This is how the industry works. These are the rules. Musk approached problems by breaking them down to their fundamental truths and reasoning up from there. Take battery costs. In 2008, industry experts said battery packs cost $1,000 per kilowatt hour. At that price, electric cars would never be affordable. Musk asked, what are batteries made of? Cobalt, nickel, aluminum, carbon, polymers. What do those materials cost on the London Metal Exchange? The answer, about $80 per kilowatt hour in raw materials. The conclusion, if we can figure out how to combine those materials efficiently at scale, we can reduce battery costs by more than 90%. So Tesla built the Gigafactory, the largest building in the world by footprint, to manufacture batteries at unprecedented scale. By 2020, Tesla had driven battery costs down to $110 per kilowatt hour. The industry said it was impossible. Tesla did it anyway. Traditional automakers outsource up to 80% of their components. They assemble cars. They don't build them from scratch. Tesla took the opposite approach. Radical vertical integration. They designed their own chips, developed their own seats, manufactured their own battery cells, even developed their own AI for autonomous driving. Why? Control and speed. When Toyota wants to make a change to a car, they have to coordinate with dozens of suppliers. The process takes years. When Tesla wants to make a change, they can do it in weeks, sometimes days. During the Model 3 production ramp, Tesla was making design changes and implementing them on the assembly line in real time. It was chaos. It was incredibly difficult, and it gave them an innovation speed the industry had never seen. Tesla pioneered massive casting machines that could create entire sections of a car from a single piece of aluminum, replacing 70 parts with one. They integrated the battery pack into the vehicle structure itself, making it both stronger and more efficient. These weren't incremental improvements. These were revolutionary manufacturing advances. But perhaps Tesla's most profound innovation was recognizing that modern cars should be software-defined, not hardware-defined. Every Tesla is connected to the internet. Every Tesla receives regular over-the-air updates. And this changes everything. Traditional cars are static. You buy them, and they slowly depreciate in value and capability. Tesla's cars improve over time. They get faster. They get new features. They become more capable. One software update increased acceleration. Another added video games. Another introduced dog mode to keep pets comfortable. Yet another extended the range of existing vehicles by optimizing battery management. And then there's autopilot. autopilot. Tesla's semi-autonomous driving system gets better every month, learning from billions of miles driven by the entire fleet. It's like having a product that becomes more valuable the longer you own it. This was the tech industry playbook applied to automobiles, and traditional automakers had no answer for it. On March 31, 2016, Tesla unveiled the Model 3. Priced at $35,000, it was the affordable electric car the world had been waiting for. Within a week, 400,000 people had placed deposits. It was the most successful product launch in automotive history. But turning those reservations into actual cars nearly destroyed the company. Musk would later call 2017 and 2018 production hell. Tesla had promised to build 5,000 Model 3s per week. They could barely make 2,000. The problems were everywhere. The automated assembly line was too complex. Robots couldn't complete tasks. The process had to be reworked constantly. Analysts predicted bankruptcy. Short sellers bet billions against the company. Major media outlets ran countdown clocks to Tesla's supposed demise. Musk practically moved into the factory. He slept on the floor. He worked 120-hour weeks. The entire company mobilized. In a move that seemed desperate and absurd, Tesla erected a giant tent in the parking lot and built an additional assembly line inside it. Automotive experts mocked the idea. And then, on the last week of June 2018, Tesla produced 5,031 Model 3s. They'd hit their target. It was a turning point. Tesla went from producing a few thousand cars per quarter to hundreds of thousands. The company that was supposedly weeks from bankruptcy suddenly had a path to profitability. While other automakers waited for someone else to build charging infrastructure, Tesla built their own. The Supercharger network. This was another example of first principles thinking. If the biggest barrier to EV adoption was range anxiety and charging time, eliminate those barriers yourself. Tesla installed thousands of supercharger stations along major routes worldwide. They were fast, charging a Model 3 from 10 to 80% in about 25 minutes. They were reliable, and they were free for early Tesla owners, then affordably priced for everyone else. The Supercharger network integrated seamlessly with Tesla's navigation system. Plan a road trip, and the car automatically routes you through charging stations, preheating the battery for optimal charging speed. This infrastructure became a massive competitive moat. Other manufacturers might build competitive electric cars, but they couldn't replicate a decade of infrastructure investment overnight. Remember the master plan? It wasn't just about cars. It was about sustainable energy. Tesla acquired SolarCity in 2016, Musk's cousin's company, and began offering solar panels and solar roof tiles. They developed the Powerwall, a home battery system that could store solar energy and provide backup power. In South Australia, Tesla built the world's largest lithium-ion battery in just 100 days, winning a bet and solving the region's energy crisis. The battery responded to grid fluctuations in milliseconds, far faster than traditional power plants. Tesla was creating an entire ecosystem: solar panels on your roof, a battery in your garage, an electric car in your driveway, all working together, all controlled by software, all contributing to a sustainable energy future. The vision was never just to replace gasoline cars. It was to reimagine energy entirely. To achieve true scale, Tesla needed to manufacture globally. The Gigafactory strategy expanded worldwide. Gigafactory Nevada, batteries and powertrains. Gigafactory New York, solar panels and electrical components. Gigafactory Shanghai, complete vehicles for the Chinese market, built in record time, just 357 days from breaking ground to first deliveries. Gigafactory Berlin, European production hub. Gigafactory Texas, home to Cybertruck production and Tesla's new headquarters. The Shanghai factory was particularly significant. Built during a trade war and a pandemic, it demonstrated Tesla could execute at high speed anywhere in the world. Chinese EV companies had been expected to dominate their home market. Instead, Tesla became the best-selling EV brand in China. By 2020, Tesla had proven the market existed. Every major automaker announced ambitious EV plans. Ford's Mustang Mach-E, Porsche's Taycan, Volkswagen's ID series, GM's Ultium platform with plans for dozens of EV models. The competition had finally arrived, and many predicted it would crush Tesla. After all, these were established companies with decades of experience, established dealer networks, trusted brands. How could Tesla compete once the big players got serious? But something interesting happened. As competition intensified, Tesla's sales accelerated. In 2020, Tesla delivered 500,000 vehicles. In 2021, almost 1 million. By 2022, they were approaching 1.4 million. Tesla's market capitalization surpassed every other automaker combined. A company that sold a fraction of the vehicles was worth more than Ford, GM, Toyota, and Volkswagen put together. How is this possible? Looking back at Tesla's Tesla's rise, a clear playbook emerges, a methodology for disruption that could be applied to almost any established industry. Principle 1. Challenge every assumption. The automotive industry was built on a century of accumulated wisdom. Tesla questioned all of it. Assumption: cars need dealer networks. Tesla: sell directly to consumers online. Assumption: cars depreciate immediately. Tesla: build cars that appreciate through software updates. Assumption: manufacturing requires complex supply chains. Tesla: vertically integrate and control more of the process. Assumption: customers won't wait for custom orders. Tesla: build to order, not to inventory. Assumption: marketing requires huge advertising budgets. Tesla: spend zero on advertising, let the product speak. Each challenge revealed inefficiency. Each disruption created advantage. Principle 2. Make technology your core competency. Traditional automakers are manufacturing companies that use technology. Tesla is a technology company that manufactures cars. That distinction matters. When autonomous driving required more computational power, NVIDIA wanted $800 per car for their chips. Tesla designed their own chip, achieving better performance at a fraction of the cost. Tesla collects data from millions of vehicles driving billions of miles. This dataset is nearly impossible to replicate. It's their autonomous driving mode. When battery costs needed to drop further, Tesla didn't wait for suppliers. They invented a new cell format, the 4680, and figured out how to manufacture it themselves. Technology isn't a department at Tesla. It's the company's DNA. Principle 3. Build a mission-driven culture. Tesla's mission is explicit: accelerate the world's transition to sustainable energy. This isn't marketing speak. It's the North Star for every decision. In 2014, Musk announced Tesla was opening all their patents. "If we clear a path to the creation of compelling electric vehicles," he wrote, "but then lay intellectual property landmines behind us to inhibit others, we are acting in a manner contrary to that goal." Competitors scoffed, but Musk understood something crucial. Tesla wins if electric vehicles win. A rising tide lifts all boats, and Tesla built the biggest boat. This mission attracts different kinds of employees. People who will sleep on factory floors, work impossible hours, and solve unsolvable problems not for stock options alone, but because they believe the mission matters. Principle 4. Move fast and iterate. Traditional automakers spend years perfecting a vehicle before launch. Every detail refined, every supplier vetted, every process optimized. Tesla launches beta products and improves them in real time. Full self-driving is still in beta after years. Tesla ships it anyway, improving it incrementally through hundreds of thousands of users providing real-world data. The Cybertruck launched with an unconventional design, manufacturing challenges, and plenty of criticism. Tesla shipped it anyway, learning and improving through production. This tolerance for imperfection, this bias toward action, gives Tesla a speed advantage incumbents cannot match. Principle 5. Ignore the noise. For over a decade, Tesla has been a week away from bankruptcy. According to critics, the company was doomed when they couldn't produce the Roadster on time, doomed when the Model S launched, doomed during Model 3 production hell, doomed when competition arrived, doomed. Musk and Tesla learned to ignore the critics and focus on execution. When short sellers bet against the company, Tesla delivered record quarters. When analysts predicted failure, Tesla expanded globally. This sometimes manifested in controversial ways. Musk's Twitter behavior, bold promises, and confrontational style. But beneath the noise was relentless execution. The lesson: if you're disrupting an industry, criticism is guaranteed. The only question is whether you let it distract you. Tesla's greatest achievement might not be their cars. It might be forcing the entire automotive industry to change. GM pledged to go all-electric by 2035. Ford invested $50 billion in EV development. Volkswagen committed to $89 billion for electric and digital technology. Every major automaker scrambled to develop electric vehicles, not because regulations demanded it, but because Tesla proved the market existed. Billions poured into battery production. Charging networks expanded globally. Governments accelerated incentives and infrastructure investment. By 2024, electric vehicle sales had reached millions annually worldwide. Transportation emissions began declining. The impossible had become inevitable. One company, told it would fail, changed the entire industry's trajectory. But disruption comes at a cost. Musk has been open about the toll Tesla took on him personally. Failed relationships, public breakdowns, constant stress and criticism. Tesla's intense culture burned out employees. The company faced criticism over working conditions, safety, and labor practices. The same drive that enabled impossibly fast execution also created an environment many found unsustainable. Aggressive deployment of semi-autonomous driving led to accidents and deaths. Critics argued Tesla moved too fast, prioritizing prioritized growth over safety, and overpromised on capabilities. Even the environmental mission faced contradictions. Lithium mining raises ecological concerns. Gigafactory construction faced environmental protests. No disruption is clean. These complications don't erase the achievement, but they complicate the narrative. Disruption is messy. It breaks things. Not all breaks are worth celebrating. Tesla's story isn't finished. The Cybertruck represents a bold bet on utility vehicles. The Semi aims to electrify trucking. The next-generation Roadster promises impossible performance specs. And then there's autonomy. Musk has bet Tesla's future on solving full self-driving, transforming the company from an automaker into an AI and robotics company. The Optimus robot, a humanoid machine Tesla believes could be bigger than their car business. It sounds absurd, just like electric cars once did. Meanwhile, competition intensifies. Chinese companies like BYD produce EVs at lower costs. Traditional automakers catch up on technology. Tesla's advantages narrow. The company that disrupted an industry must now avoid being disrupted itself. But Tesla's playbook extends beyond automotive. Musk applied the same principles to space exploration with SpaceX. Reusable rockets, vertical integration, first principles thinking. The playbook worked again. Other industries face similar disruption potential. Finance, healthcare, construction, energy, education. Each contains entrenched players, accumulated inefficiency, and assumptions waiting to be challenged. The Tesla playbook offers a template. Challenge every assumption. Make technology core to your mission. Build around a compelling purpose. Prioritize speed over perfection. Ignore critics and execute relentlessly. In 2003, electric cars were a joke, a failed experiment from the 1990s that proved consumers didn't want them, couldn't afford them, and the technology wasn't ready. In 2025, electric vehicles are the future. Every major automaker is investing billions to transition their fleets. Governments worldwide are setting deadlines to phase out internal combustion engines. What changed? Tesla proved it was possible. They showed that electric cars could be better. They demonstrated that a startup could challenge century-old giants. They made the impossible inevitable. Elon Musk's playbook for disruption wasn't about having better technology or more money. It was about thinking differently, questioning assumptions, moving fast, believing in a mission larger than profit. Tesla's rise is a case study in how one company can change an entire industry, how persistence can overcome skepticism, how a clear mission can attract talent and create movements. But it's also a reminder that disruption is brutally hard. It requires sacrifice. It creates casualties. Success is never guaranteed, and even when achieved, comes with complications. The automotive industry will never be the same. The rise of Tesla didn't just create a successful company. It transformed how we think about transportation, energy, and what's possible when someone dares to challenge the way things have always been done. The impossible dream became reality. The playbook was written, and the revolution is just beginning.